This is Richie Carmichael, and this is a presentation on integrating ArcGIS with next generation devices. We're going to look at Kinect, Leap, motion controller, and Windows tablets. First of all, the group I belong to is called the Prototype Lab, based here in Redlands. There's 13 of us. We do mostly pre-sales, but most of the time is actually doing prototyping, where we try to integrate with new technologies or hardware. First of all, Windows Store or Windows Store apps. And this is apps developed using the new runtime for .NET, specifically for the Windows Store portion of the .NET runtime. In this first application, we developed using the .NET runtime for Windows Store. In the background is a presenter. He's presenting a map to an audience, and in the foreground is a person in the audience holding up a tablet, and the person in the audience wants to follow the presenter's presentation. And what happens is, as the presenter in the background pans and zooms this map, the QR code is updated and it's recognized by the camera in the mobile device. So as soon as the presenter moves, the map in the audience's tablet also pans and moves. The technology used is zebra crossing. This is an open source library that's used to encode, decode and encode barcodes and QR codes, as well as other codes. For this technique, we did come across a problem in that we need to compress the map extent that was displayed in the QR code. But because the map extent was too long, that resulted in the coding being too fine. So we had to develop our own sort of shortening technique in which we could compact the map extent, so the resulting QR code was more coarse and could be more easily recognized by the camera in the back of the Windows tablet or the Windows Surface. In this next demonstration, we have two devices side by side. They've established a Wi-Fi connection, a private Wi-Fi connection that is called Wi-Fi Direct. This is a new standard that many mobile devices support. It allows peer-to-peer connectivity over a localized Wi-Fi network. It's extremely fast because the communication does not need to pass through a router. So that was an example of two people exchanging graphics peer-to-peer. And this example shows the exchange of map extents. Similar to the first demonstration, but in this one, once the user has finished marking up his map, you'll see that with the exchange of map extent, you get this illusion that the devices are connected. Because at the beginning of the demonstration, the user on the right offset his screen. So you get this effect of a multi-screen display. Let's just summarize what we saw. With the recent release of Windows 8.1, you could establish connectivity between two devices by tapping using the near-field communication. This is a very sensitive connectivity. When devices get within 4 centimeters of each other, they can exchange very small bits of information. So they can be used for two devices to identify each other, and can be used to start off a Wi-Fi direct communication, or perhaps a Bluetooth network. This is an augmented reality app. In the background there's a marker that's been recognized by the camera feed, the video feed in the back of the Surface. And the orientation of that marker is being used to drape the map in 3D, as shown. So in this app, what it does, it searches for Landsat scenes that overlap a specific area. These are just ordered by the data capture. So Landsat goes back 40 years, and using this slider, the user is able to interrogate older images near the bottom of the stack. Next, it's going to change the order so that it's now stacked by percentage of cloud cover. So the clearest images are on the top and the cloudier images are on the bottom. So this is an interesting use of augmented reality, a way of manipulating graphics in 3D. The Augmented Reality Toolkit is an open source library. We actually we ported the Silverlight version of this toolkit to Windows Store. This is a game we developed. The interesting thing here is the game is powered by ArcGIS Online. The initial authentication is provided by ArcGIS Online. This is a OAuth 2 authentication. And the reason why you want to log in is because eventually you want to store players' scores online. We're starting the game here. I'm going to go through answering a few questions. What is this place? What city is this? And every right answer, the scores, you add only 10 or 20 points. What's interesting here is that the quizzes or the questions are stored as a hosted feature service on ArcGIS Online. So eventually, it gets the wrong answer and the game's over. The score has been uploaded to ArcGIS Online, and now I can actually view all the high scores for all time. So again, the scores are also stored as in a hosted feature service. I don't have a video of this, just a screenshot, but this is another example of using the Windows Store SDK. And this app allows people to select a language on the right and then click on a country and say the name in that language. And the voice recording is uploaded to a hosted feature service and stored as an attachment against a feature service. And because more than one attachment can be associated with a feature, you could record many different country names in different languages. So I use this to go around the office to all my colleagues and get them to say the name of different countries in their own native language. And then at any time you can play back the country names. I guess, why would someone create a Windows Store app? There are a few reasons why you'd like to, including if you have developers who are already experienced in C#, XAML, and the .NET languages. Recently, Microsoft introduced the concept of a universal app. That is a special project that you can use to share code between share code for projects that target different devices: Windows Store apps, .NET, and Xbox One, and Windows Phone. So 4 different types of platforms originating from one single code base. The other great reason you'd want to do a Windows Store app is because of the abundance of drivers. So every sort of map, printer, plotter, camera, microphone, it's quite likely that there's a Windows driver for that device. So that's the reason why you want to stick within the Windows Microsoft ecosystem. Another reason is that if you install the latest update of Windows 8.1, you'll see this little green icon in the taskbar. That will direct a user immediately to the online store, where they can download and install these apps, hundreds of thousands of apps. So one of those apps could be one of yours, based using hopefully the ArcGIS Runtime for .NET. And there are some pain points. Deployment is one of them. For the work that I've been doing, I've been using developer licenses. This is a free 30-day license that has to be renewed at the end of those 30 days. It's easy to do, but it means that every month you need to enter in your Microsoft credentials to renew the license. And it's supposedly for non-commercial use. If you want to deploy it so that everyone can use it, you can pay $100 and get it uploaded to the Windows Store. But in many cases, you only want your application to go to your colleagues or to your organization or for your customers. To do that, you need to use side loading, and this requires a separate license. There are some pain points in addition to what I just mentioned. And one of them is the huge variety in sizes of screens, from small Windows tablets to very large Windows displays up to 80 inches, for example. And the second thing is that big variety of resolutions. These days, the screens are coming up with full 1080p as standard, but there's also talk of 4 and 8K resolutions. In addition to that, developers need to consider rotations of devices, but also the technique of snapping. This is a Windows Store technique of moving the window to the edge. So the developer needs to keep in mind what they want to do when the application is sidelined like that. Okay, now we'll move on to the Xbox Kinect or the Windows Kinect. And this first demonstration, this is our first experimentation with the Kinect. This is an add-in to ArcGlobe. So straight away you see that it's recognizing this, the person and it's overlaying a skeleton. And the user here is using their right arm in what we call the Superman tool. Wherever he points his arm, that's the direction of flight. And when he uses his other hand or other arm, that becomes a rotation tool. So here it's rotating around the point of view. When using both arms together, it sort of simulates like a pinching operation that you do on your iPhone to zoom in and out. In this next example, this is a runtime using the ArcGIS runtime for WPF and the Kinect for Windows SDK. And we've taken advantage of the audio recognition of the Kinect. Just by initially starting with 2005, he waved his hand over the map, and it painted the screen with Landsat from 2005, and then he said 2000, and it showed the early epoch of imagery. And it's quite interesting to see in just 5 years how those resorts on the coast of Dubai were constructed in just 5 years. And here we're zoomed out to a larger scale. And this is showing all the Landsat scenes for this area of the Middle East. And just by putting his hand, it's doing like a mouse over and identifying the results. And with two arms raised and saying the voice command open, is able to rotate the scene in 3D. And you can see that the images, the Landsat scenes are stacked based on the data capture. The scenes near the top are the most recent, and the scenes at the bottom of the stack are older. So the Kinect's been around for 4 years now. It started off exclusively for the Xbox, but then Microsoft released a special version of the Kinect for the Windows device. And with the latest one, with the Windows Kinect for Windows version 1, it included a Neo mode, so you could use it for up to 50 centimeters away. And this was really designed for like the desktop users, so the device could be sitting on the desk. And they also added support for body recognition, just your upper half of the body, again for use behind the desk. Just a week ago, Microsoft released the second version of the Kinect for Windows 2. More information about the sensors. What's interesting here is the microphone array. There's actually 4 microphones within the Kinect. And the reason for this is that so they can isolate the direction where a person is speaking from, or people from. So in theory, you can isolate the 8 people within a room and isolate who is saying what. Here's an example showing the raw feed from the Kinect using the SDK, the raw video feed on the left and the raw depth feed on the right. By itself is useful, but not as useful as some of the derived information. And here's an example of some of that. On the left is the skeleton of a sitting person and a standing person. So that you can toggle these mode, either standing or sitting mode. You can ask the Kinect to just recognize the upper half of the body. Also, there's 87 points recognized from the face. For this to work, you really need to be sitting very close to the Kinect to work. Over on the right, it shows the coloration of the depth feed. So from the depth feed, which is infrared based, you can actually isolate parts of the screen, or pixels from the depth feed can be tagged by which person in the room. The Kinect supports a couple of basic built-in gestures. One being a circle with the arm. Another one is grasping, so you can actually grab things and drag them left and right. That'll be very useful for mapping applications that you want to pan the map. Another new one is waving. So in the case, for example, when you're using the skeleton model, Kinect will automatically recognize the 2 nearest people closest to the Kinect, and you can iterate through the skeletons of those 2 people. By default, you normally use the person closest to the Kinect to operate the controls or interact with the menu system. You can use the wave gesture to identify one person over the other. Perhaps the person who wants to control is not closest to the Kinect, so that's quite a useful advantage. Kinect Fusion, this is an add-on. This is a utility recently developed by the research team. The Kinect Fusion is when you use the Kinect device like a 3D scanner. You should pick it up and you can scan around a body, a person, or an object, and it'll create a 3D mesh, put like a LiDAR, on the fly create a 3D mesh. So create a 3D point cloud, and from the point cloud it creates a mesh. And that mesh can be exported in a number of formats, one of which is OBJ file, which I believe can be imported into City Engine. And that also supports color mapping as well, so you can have a textured mesh. Last is background masking. That's when you can basically replace the background with some other scene image. So I just want to comment that we're not quite at the point of Minority Report, but with the new Kinect, we're getting pretty close. This is Kinect version 2. It just went on sale about a week ago. It's for $200. It now has a higher resolution depth sensor, but also the video camera is filming at full HD or 1080p. The depth sensor has a longer range. They officially say the range is 0.5 meter to 4.5 meters, but they say it can still detect objects up to 8 meters away. The infrared camera has been improved so they can view objects in low light or no light. So ideal for mapping the interiors of dark rooms, for example, or people as well. Skeleton tracking has improved quite a bit. You're tracking 2 people now up to 6 people at any one time, and from number of joints from 20 up to 25. The new joints or locations on the body include the thumb and the tip of the hand, and also the number of facial features has increased from I think 80 to 94. Now we're going to move on to the Leap motion controller, and this first demo by my colleague is using the iOS the the Mac SDK, the runtime for the Mac SDK. And he's using the Kinect, which is pictured in the foreground there, to select menu items by flicking his hand. So these are many gestures recognized by the Kinect. The downward flick, they call it keyboard flicks. And he's using his fingers to pan around, zoom in and out. And also using the circle gesture with the Kinect to bring up the menus when he wants to change the map operation. And what's interesting is the Kinect can recognize objects like a pen, automatically recognize a longer object, which can in this case be used to do some redlining on the screen, actually editing or digitizing. This is another Leap demo, and this time this is an add-in for ArcGlobe. This add-in in conjunction with the Leap SDK is using the Leap like a 3D mouse. So unlike a mouse which moves in just one plane, using the Leap controller you can move your hand in all three directions, three dimensions. So it's very easy to use. You just push your hand forward to fly forward, you pull it up to fly up, or down to go down. But also rotation in three axes as well. So you can reorient the observer just by rotating your hand slightly in one direction. That's a free tool, and the source code is published on ArcGIS.com. So conceptually, the Leap and the Kinect are very similar. The major difference is the range. The Leap has a range of 1 meter. So basically, it's just the objects around you that it can sense. It can sense currently, I think, 4 hands at one time. 4 hands and all the fingers in the 4 hands. Oculus Rift, this is mostly related to the work of my colleague. I don't know too much about this, but I believe from City Engine you can export a scene directly to Unity 3D, and from Unity 3D you can create an executable which contains the data and the Unity runtime. And the application contains 2 displays. So this is so that one display for each eye. So you can replay this application using the Oculus Rift device. And that was a presentation by my colleague Krishna Jagadish at the 3D forum at the user conference. And these are 2 videos I found on YouTube which describe in detail how to export a scene from City Engine and import it into Unity. That's the end of our presentation. Our lab has a blog that we talk about many of these applications in greater detail. We have links to videos, to the source code. In the case of web apps, we have links to web apps as well. Maps.esri.com is a portal where we host many of our web apps, and there's a guest login for the public to log in there as well. That concludes my presentation. Thank you.